Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download a free PDF copy of issue number 8 of the New Thinking Aloud magazine or order a beautiful printed copy. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today, we'll be exploring the findings of the Princeton PEAR Laboratory. With me is Brenda Dunne, who for 28 years served as the laboratory manager of the Princeton Engineering Anomalies Research Laboratory. Along with the director of that laboratory, Robert Jahn, who was also the dean of the School of Engineering at Princeton, she has co-authored a number of books, including Being and Biology, Is Consciousness the Life Force? Margins of Reality, The Role of Consciousness in the Physical World. Consciousness and the Source of Reality, The PEAR Odyssey. Molecular Memories and Quirks of the Quantum Mind. Welcome, Brenda.
Thank you, Jeffrey. It's great to be here.
It's great that I got through the list of books.
You did. Very impressive. It was not chronologically accurate, but that's okay because it didn't have to be.
And it wasn't complete. I know there's yet another anthology that you
right.
and Bob Jahn edited as well. So you've been very productive, and you were the laboratory manager for 28 years at Princeton. That's a long run.
It was indeed a long run. One of my favorite T-shirts reads, "What a long, strange trip it's been."
Well, the laboratory was known primarily for the hardcore engineering, the human-machine interface, the quantum mechanical random event generators that, according to all conventional physical theories, are imperturbable by human thought.
That's correct. We had an array of random physical systems or devices. We had a microelectronic random event generator. We had a very large macroscopic random mechanical cascade, fondly known as Murphy.
Mm-hmm. We're talking now about thousands of balls.
We're talking Murphy trickled 9,000 little 3/4 inch marbles down through a maze of some 300 and odd pegs into 19 collecting bins. It was very noisy. It was, that machine had a personality. It earned its name Murphy because anything that could possibly go wrong with it did. But it was, a macroscopic device that was essentially designed to represent, statistical probability. And, it was, big. 9 feet tall and 10 feet wide. It was huge. And it took one whole wall of our laboratory, but it was a delight. But we also had other devices. We had a pendulum that people would attempt to change the swing, the rate of its swing, and it would change color. We had a fountain where people would attempt to change the height of the I mean, all of these devices were works of art. They were kinetic sculptures. They were designed not only to be extraordinarily accurate and sensitive, but they were also designed to be beautiful. And people came and interacted with them. We encouraged them to play. The important thing about our lab was we did not study people. We were studying the machines, and we were asking people who were volunteers, people who were anonymous, who didn't have any claim to unusual abilities, to just come in and play and see if they could influence the way these machines turned out their random output.
Well, I know there's an enormous lore amongst users of machines of all sorts that, when I'm in a bad mood, the machine responds to my bad mood and things of that sort.
Oh, I've had countless letters from people. There's a group that call themselves the, streetlight interference slider.
From the movie Bell, Book, and Candle.
Yeah, who claim that when they walk down the street lights blow out. And I've had that happen. I've had it happen sequentially. But it seems to be a fairly common, it seems that electronic equipment seems to be particularly vulnerable to this sort of anomalous, telephones, computers, tape recorders,
watches.
I have never been able to wear a watch. I break them. I don't know what it is. I don't know if it's something physical or something in the aura, whatever you want to call it, of a given person, but it's very common. People write to me all the time, and, I just have to go back and say, look, we can't explain it. The only thing I can tell you is that based on the correspondence we receive, what you're experiencing isn't all that strange. And people seem to be grateful to hear that.
So in effect, the purpose of the laboratory was to test the hypothesis under really controlled conditions, that there's some sort of an interaction between the human being and the machine that is not explainable by conventional heat and cold and electrostatic radiation and the sorts of conventional explanations one might come up with.
That's true. We actually spent most of our time calibrating all of our equipment to be sure that it was not vulnerable to any kind of artifact, temperature, humidity, vibrations in the building, air conditioning cycles, and so forth. That was really essential. If these experiments were to be reliable and if the results from them were to be believable, we had to be doubly sure that there was no possible influence other than the connection with the human operators. So that was really the focus of those human-machine experiments. I can vouch for the reliability of every one of those devices ad infinitum. We would leave things running to calibrate over weekends. We would leave it running and do recordings and looking for correlations with air conditioning cycles. You name it. We even had one experiment, our pendulum experiment, that turned out to pick up vibrations of waves on the Jersey Shore. It was that sensitive that we didn't know what it was. It took us quite a while to track that down, but that's how careful we were.
So, in other words, when nobody was attempting to focus their intention on influencing these random devices, you got the expected baseline within the chance expectation,
Correct.
within the chance range. But then if people were endeavoring to influence the device simply through mental effort, then you found deviations.
Right. And it was more than mental effort, it turned out. Our primary variable was intention. That was something we could record. I want to get high numbers. I want to get low numbers. I want the balls to go to the right. I want the balls to go to the left. But our operators would tell us, it's more than that. It's not just a question of having an intention. I have to have an emotional connection with the process. I have to feel resonant with it. That was an important point. And it turns out that you can measure intention. I want to go high, I want to go low. It's a little more difficult to say, she loves me not. That's something that either is or isn't. So we ended up doing a body of experiments that we called field reg, okay? The reg standing for random event generator. And we developed these portable random event generators that you could connect with the laptop or these mini computers at the time. You could take it, put it in your purse or briefcase, take it out to an event that might produce a resonant environment. It might be a concert. It might be a meditation group, a religious service. You name it. But there are places and experiences where there's a group of people and, you're all sort of on the same wavelength. We've all felt that at one point or another. Yeah. It's hard to define it, but you're there. And, the machines would just run continuously. And the person carrying the machine would just push a button on the computer to mark a period when they thought that there was this resonance. We also took it to very mundane environments, lectures, business meetings, your name, nothing happened. But when we took it to these environmentally coherent or resonant situations, lo and behold, the random event generator would produce a more resonant, coherent output.
Like a concert.
Yes. Or as I say, maybe it's a religious service, whatever. This was actually the experimental process that became the core of the program that Roger Nelson later developed called the Global Consciousness Network. Because he was then saying, well, what if you had a whole bunch of random event generators all over the world? Would they respond together to events that had a worldwide emotional impact? And indeed, I'm sure Roger has described that when you spoke with him.
In fact, what I'm going to do, if our viewers look at the upper right of their screen, they can link directly to the interview with Roger about the Global Consciousness project. But in focusing on the PEAR lab per se, you were doing these remote exercises with the generators. And one of the striking findings that you've described in some of your writings is that there was a sex difference between the male and the female operators. Well,
this was all part of this bidimensional, if you will, intentionality and resonance. Something I'm just trying to think. We were not able to study the people in our program. The one thing we were able to do was to just look on a purely superficial level at whether our operators were men or women. Okay? If they happened to be gay or lesbian or whatever, we didn't know that. I just figured you had hair on your face, I'll call you a guy. You have breasts, I'll call you a woman. And, the rest of it is... and we just looked at the results of the male and the female operators. And much to our surprise, we found a very strong difference. A lot of people thought, women are better at this sort of thing than men are. It's not true. Turns out that the male operators were better at getting the results in the direction they wanted. Their highs went high, their lows went low, their baselines were very well behaved. They were much too well behaved. In fact, their baselines had much too small a variance. That is, they didn't wiggle around as much as you'd expect.
So they were told, don't try and affect it either way, but they were affecting it to stick very closely to the mean.
The fact that baseline, those baselines were showing effect has powerful implications. Because, of course, that raises questions about any scientific study where you're doing some baseline comparison. But it was interesting because the males got these results in the direction they wanted, but their effects were very small. The females got much bigger effects, but they weren't correlated with their intention. Their highs would be huge. So would be their lows. And so would be their baselines. So they were getting this very large excursion.
Variability.
But it was not correlated with their direction of intention. The males were getting a correlation with direction of intention, but the effects were very tiny.
Well, so are you saying the females scored opposite the direction
Sometimes.
of intention?
Or they scored only in one direction. And since our hypothesis said there'd be a difference between the high and the low, and if they were both very high, you couldn't claim that was an effect, even though both of them were way beyond chance. So this got us looking into a lot of the studies that had been done on gender differences. I was we looked at hundreds of papers in every field, you know. There have been loads and loads of studies on gender differences, but interestingly, there's been very little that's been found conclusively.
Yeah.
Two things mainly, that men are better than women at spatial orientation, and women are better than men at communication. Interesting. So I looked at that and I said, I have just solved the problem, the age-old problem of why men don't like to ask for directions. Indulge me on this, because this is pure speculation. In many species, particularly a lot of mammalian species, men play, or the male plays the role of defining and defending territory. A male that doesn't know where he is in trouble. Okay? The females frequently band together as groups to protect the young, or they hunt, you take care of the babies while I go catch a, deer or whatever. And, therefore they need to communicate with each other and create these bonds. So now you've got a situation where it would make some sense for females to be better at resonance and males to be better at directionality, spatial orientation. So we thought this was fascinating. So we carried out another body of experiments where we said, let's look at what we called co-operators, two people attempting to have an effect together simultaneously on any of the machines. It turns out that when the two people were the same sex, their results were pretty close to chance. When they were of opposite sex, a male and a female operator working together, they were getting effects that were about twice as large as what they got as individuals. But it doesn't end there. If it turned out that the couple, the male-female couple, was what we called a bonded pair, they were in love with each other, okay? They were getting results that were almost 7 times larger than what they produced individually. What does this have to do with anything, we say?
Well, it's quite consistent with a lot of folklore that, people who fall in love begin experiencing telepathy. But, we were supposedly studying engineering science, not folklore, and here were these implications that we were discovering. For example, another interest, I think I may have mentioned, we found no effect due to distance or time separation, whether in the human machine or the remote perception experiments. It didn't matter how far away you were, or from the machine, or when the machine was running. You could be thinking about the machine running next Tuesday, today, and we would turn on the machine next Tuesday and, look at the data that it produced at that time, even though you were thinking about it a week ago. So now we've got this independence of space and time. We've got this gender correlation that's strange. Then we get this, what we could call series position effects. Now, in the parapsychological world, this phenomenon was called the decline effect. Because you see, parapsychologists tended to be studying the people. Okay? So for that purpose, you want to get a lot of people doing a relatively small amount of data, because you're looking at the people. In our case, we wanted a relatively small number of people producing lots and lots of data. So we had a lot of people that would come in and they would do an experimental series and come back, do it again and again and again. And we would encourage them to keep coming back and, and play.
And what we discovered was that people tended to get the largest effects on their first trial when they had no expectation of what.
The well-known first-time effect.
Right, the beginner's luck.
Yeah.
Then they'd come back, they're confident. Now they know what they did, they're going to repeat it.
Yeah.
Doesn't
Scores
work.
drop.
Scores drop.
Yep, that's been found in many, many other studies.
But you see, we didn't stop after just 2 trials. We had people coming back and doing at least 5 or 10 or even 20, okay? And what we found was that after the 3rd trial, it was like they're back to this state of, what's going on here? Okay, first time, I don't know what's going on. High uncertainty. Catch that word.
But also the thrill, I think, of knowing, gee, I did something I didn't expect. Yeah.
But then you come back and you say, I can do that again. That was easy. Okay? Now you have an expectation. Now you think you know what you're doing.
And you set yourself up for deflation.
And it doesn't work.
Yeah.
By the 3rd time you come back and say, I don't know what's going on here. You're back to uncertainty again. Well, I thought it worked, but maybe that was just chance.
Right.
Well, when we looked at the traces of people who did at least 5 experiments, the very first trial would be big effect, or series, really, which was many trials. The second series would fall down. By the 3rd and more series, the effect would gradually recover.
Yep.
It never quite got as high as that first time. But what happened was it's sort of stabilized. It was almost as if people had gotten some control over their ego, over their expectations. They were back to, I don't know what's going to happen in this, but I'm going to have a good time anyway. And we saw this again across all of our experiments.
It's a familiar pattern. Sometimes in statistics, it's called a J curve.
Yep. Just so. So this was another thing. This was happening. There were a number of little things that we looked at in the course of our 28 years that were they weren't telling us what was going on, but they were sort of indicating what wasn't. And it was very clear that we were not looking at something that you could explain by any physical or psychological framework, because it was breaking all the rules. But there was one area that there was some possibility. Where else do you see a situation where you have a random process, preferably a binary one, okay, where a tiny effect repeated over many, many times could produce a shift in the output mean of that distribution? Evolution, perhaps?
Evolution would be a perfect example.
Exactly.
Yeah. The tiniest little influence on the probabilities. If living systems can influence probabilities, that would explain how over billions of years life has evolved on this planet.
Or over billions of consciousnesses working together. And
the tiniest little effect on probabilities over billions of years will lead to, amongst other things, the biological diversity that we now have and the complexity of vertebrates and mammals. And
well, it's not just vertebrates and mammals. I mean, it's also rhododendrons, or not philodendrons.
Roses.
Oh, roses. I mean, what's the difference? This rose wants to be red. No, I want to be yellow. Is it pure genetic manipulation? Is it possibly a desire? Why limit it to humans or even to animal species? Our baby chicks. The plants, the universe itself. This is all this interconnected web of desire to survive, to grow, to become more complex, driven not necessarily by conscious intention, but by this life force that is driving toward more complexity, more extensive realities. And that was why we started thinking along those lines. That's the thesis, of course, of the book you mentioned called Being and Biology. Is consciousness the life force? Maybe what we are calling consciousness is not something that has to do with our brain activity or our brain at all. Maybe it has to do with something much more profound, something much wider and broader. Spell consciousness with a capital C. And maybe we're talking about an organizing principle that's the force of the universe, where you have this consciousness, this organizing principle here, and you have this chaotic principle here, and you've got this yin-yang interaction between them of entropy and syntropy, if you like, that is constantly interacting. It's like the book of changes, the I Ching. Everything is always the same, and yet everything is constantly changing. Yeah. And the change tends to be probabilistic. You can't predict exactly how it's going to go, but you know that it can, you know it's going to change.
Well, and viewers of New Thinking Aloud who watched the earlier interview with Bruce Damer, the biologist who's working on the origins of life, describes the life process as a probability aggregator. That even the progenotes, the pre-living structures that eventually formed into living cells, were also probability aggregators.
Absolutely. And when you go into the physics and you get into the world of quantum mechanics, you find yourself facing this concept that everything at the subatomic level is probabilistic. They talk about how an event isn't a real event, they say, until you observe it. And then you, quote, collapse the wave function. What does that mean? It means that there's some kind of probabilistic process going on that could be this, it could be that, but you don't know whether it's this or that until you look at it. Now, observation is an objectification. That's an objectifying process. I am observing you. Okay? You are either here or there, or doing this or doing that, and we're into some sort of binary either or. It's some kind of a dualistic set of probabilities. Well, then along came Niels Bohr, who said, it isn't necessarily an either or, it could be a both and. That maybe these two options are just two ways of looking at the same event. Now you're referring to the wave-particle duality. The wave-particle was precisely where it started, Is a quantum of light a particle or a wave? Right. For a long time, these early physicists were having terrible arguments over this. Some of them said, no, it's a wave. Some said, no, it's a particle. But you told me a story, Jeff, that I think exemplifies what I'm trying to say so beautifully. You were talking about taking a hike, and you're walking along and you see this rattlesnake. Oh, yes. On the path ahead of you. Yes. Okay? There's you. There's the rattlesnake. Right. You have a choice. Two probabilities. You can either leave or you can kill the snake. The snake has two probabilities. It can either strike you or it can take off. Okay? This is an objective observation. What are the options here? But something else happened, didn't it? Yes, that's right. You said you began to interact with the snake. Yeah. You started swaying toward it and away, and the snake started doing the same thing. And you said, as you described it, you said it was as if you were dancing. Yes. You were no longer dealing with an objective experience. You had a subjective experience going on. And there was a synchronicity associated with that event, because at the time I was listening to an audio of Marion Zimmer Bradley's novel, The Mists of Avalon, and I had just come upon a passage in the novel of two illicit lovers out in the forest making love, Morgan Le Fay and her lover, and the lover had ancient Pict
tattoos on his arm of snakes, the blue tattoos, and as they're making love, the snakes are starting to move, and she can see the snake's tattoos on his arm moving around.
Yeah.
And that's when I encountered this magical dance with a real rattlesnake.
I love that story because you know what happened? You had moved from an act of observation to an act of interaction.
Yeah.
And somehow you and the snake had become a molecule. You were working together. It was no longer me and the snake. It was us moving, dancing. Now the experience is over. The snake goes off here. You go off there. But the probabilities now have changed for both of you. You will never be able to see a snake again without remembering, and your body of knowledge about snakes has now expanded. Yeah. And the snakes, at least that snake's body of knowledge about humans has been altered. Like, hey, he didn't try to kill me. I didn't have to bite him. We were, however snake process. But I love that story because it says so beautifully how these binary probabilities are only one way of looking at it. That's the objective way of approaching reality. But there's the subjective, there's the interactive. There's not just you and I, but there's us. And when we share something together, like a molecule that shares atoms and electrons, we are now a different system. You're hydrogen, I'm oxygen, and together we're water. Now you go figure out how that gets that way. You can't predict water from either hydrogen, or no matter how much you look at oxygen or hydrogen, you're not going to come up with the idea of water.
Or salt from sodium and chloride.
Et cetera, et cetera. Yeah. When these two elements, and I use that word very loosely, are interacting, something magical happens. Yeah. That the realities, the definitions overlap and something new emerges. And that is the source of creativity in any field, whether it's art, whether it's music, whether it's science, but in that place, you're dealing with what Heisenberg referred to. This was uncertainty. You now had to accept the fact that there was more to it than just A or B, that the A, B was different than A plus B. And now you have to open yourself to to a horrible thought that many scientists have great difficulty dealing with. I don't know.
I don't know.
You can't say that. I am a scientist. I know. I am the authority. Yeah. If you produce an anomaly that doesn't fit my model, I have two options. It's like the snake and the Jeffrey. I can either deny that what you're telling me about is real because it doesn't fit what I know to be real. And I can now go and project that disbelief onto someone else, like the person who told me about it, like, oh God, they're crazy. Oh, they had to have cheated. They couldn't possibly, this can't happen. So I'm safe. My world is intact. Or, because it's either or for these folks, or I go into a state of cognitive dissonance. This makes me very uncomfortable. Now I have to deal with the possibility that there's something out there that doesn't fit in my belief system. And I could be wrong. I can't be wrong. I'm a scientist. No. These people are crazy. I'm not wrong. But if you're a real scientist, you're going to be able to say, well, I don't know. What was that? How can I explain that? How can that be? There must be something more than what I thought was out there. Now, Bob Jahn was that kind of scientist. So was J.B. Rhine. So were, so many. So was Niels Bohr. So, all of these creative scientists who came up with new ways of looking.
Well, you mentioned to me earlier at the laboratory you interacted with Eugene Wigner.
Yeah, he was another.
He's one of the main proponents of the idea that consciousness itself is what collapses the wave function.
Well, most of the patriarchs, if you will, of quantum mechanics believe that.
Yeah.
If one reads some of their philosophical or personal writings, it's amazing how dominant that theme was in their discussions and considerations. Mm-hmm. But Eugene Wigner, who of course had been on the faculty at Princeton, in fact, he had been a professor of Bob's when he was a graduate student. He was one of the very few members of the university faculty, probably the only member of the physics faculty that I can think of, who actually came to our laboratory to see what it was we were doing. What a charming man he was. Mm-hmm. Just a delight.
Well, I gather from your comments that over the 28 years, you must have had many opportunities to present your findings to other academics at Princeton and elsewhere.
No, we did not have many opportunities.
Oh.
We had very few opportunities. Our university would invite critics. They had invited a special honorary presentation, what you call it, an endowed lecture.
Colloquium of some sort. Mm-hmm.
To the skeptic James Randi, for example. Uh-huh. He was invited to come and speak. Bob was never invited to speak. They didn't want to hear. Bob spoke, but they were at, little personal things. Mm-hmm. The old guard, for example, this group of old alumni had him come and give a talk at one of the, it got out, but it was never an official presentation. He was not allowed to teach.
I mean, I can tell you that when I was a graduate student at Berkeley, your work was well known.
Like I said, it gets out. He that has ears to hear, let him hear.
Yeah.
But not within the university. They were very protective of their credibility.
You published the book, Margins of Reality, in 1987, I recall.
That's right.
Was the original edition. So at that point, you were getting a lot of public comments, I should think.
Not as many as you might imagine. Mm-hmm. It was a lot of it was, sort of underground, people talking to people. Yeah. But there was not, the university did not want us doing PR. We were not supposed to go off and speak on Oprah or whatever. Mm-hmm. But people came to us to film the laboratory or to do interviews. Other people heard this. And it was something I think that a lot of people wanted to hear. We were somehow putting out this message that scientists at Princeton University, very prestigious institution, were able to demonstrate that the human mind could affect the physical world.
Yeah.
This was, talk about cognitive dissonance. And yet, here was the data. These people were credible. They were doing good work. You couldn't find fault with it wasn't electromagnetic fluctuations. It was not, there was one young man who came to visit who put it so beautifully. He said, I wanted to learn more about what you're doing because I am so tired of having to choose between my head and my heart. I have both. That was great. People wanted to be able to have some kind of credible evidence for something they wanted to believe in, but were told, if you believe in this stuff, you're crazy.
Well, and some of the critics went so far as to accuse you personally of cheating.
Yes, they did. And, whenever a critic came forward with a comment that had to do with being informed. Mm-hmm. I've looked at the data. I have a problem with the statistical process you used or with the way you set up your protocol. That's fine. And we would always respond to that. But when a critic would come by and say, you're crazy or you cheated or I don't believe you because, your mother went to the wrong school. I don't know. That wasn't worth wasting our time to deal with. Mm-hmm. And it could very easily become a distraction.
Yeah. Well, my recollection, Brenda, is that when those criticisms were first raised, though you and your colleagues went to some effort to show that it wouldn't have been possible, that there were already all kinds of safeguards against that kind of cheating.
As I say, if it was an informed query, there was a a guy, I don't know if he was a physicist or a mathematician or whatever, at some conference, he approached us. He says, the problem with your experiments is your results can all be explained by the law of the iterative logarithm. Did you ever hear of this? Bob said, no. Well, we thanked him. Mm-hmm. We said we would look into it. And we went to York Dobbins, our resident statistician and physicist, and said, York, have you ever heard of the law of the iterative logarithm? And he said, no. But he went off and he looked up all the journals. He found one isolated paper that talked about this log n phenomenon that could explain certain types of statistical events. And York, bless his heart, went off. He actually ran all of our data through this particular algorithm. Mm-hmm. Turned out that there was no effect. It didn't make any difference. We wrote back to the guy and said, thank you for bringing this to our attention. We have indeed explored this possibility, and here's the results. This can't explain. We never heard from him again.
But I suppose, to be fair to some of the critics, it is the case that I think in 1973 at the Rhine Research Center, then called the Foundation for Research on the Nature of Man, they did find a researcher who was fraudulently doctoring the data.
And it's not just in this field. I mean, we find this in almost any field of science. There are people, I mean, I hate to say it's human nature. Some people have a desire and they will sell out their principles and their ethics for advancement, to get a grant, to get popularity, to get a publication.
Sure.
I mean, and that's anywhere. It's
and of course it's
in politics as well.
It's for a question of survival in academia sometimes.
You have to publish.
Yeah.
So, no, I think skepticism is an important part of the scientific process. I mean, you can't go into it believing that I know how this works. And having people looking at your work in a skeptical and critical way is very important. It's how you grow. It's how you learn. One should never sneer at a real skeptic. There's a difference, though, between a skeptic and a debunker. Mm-hmm. Skepticism is good. Debunking is ad hominem. That's not going to get you anywhere.
Well, my friend Stan Krippner likes to say he prefers to call them scoffers because he says even the word debunker implies that there might have been some bunk.
Good old Stan.
But the scoffers, really, they just want to put this field down. For them, it's a priori impossible. So anybody who claims to get an effect is either a fraud or a fool.
And furthermore, if I put you down because of the work you did, I can get a publication out of it.
Yeah.
And that increases my credibility. Yeah. And you can't get a publication for the work you did because no journal is going to want to publish it. So, and that's another very interesting aspect of this work and the PEAR program. Mm-hmm. Although we were able to occasionally get a publication in a mainstream journal, it was very difficult. Mm-hmm. We send articles out, they were turned down. When we first did our quantum mechanics paper, we sent it to the journal, the Foundations of Physics journal. They sent it out to be peer reviewed, which is the usual procedure. Usually they send it to 2 or 3 peers, people who can critique. Well, they sent it out to 5, 6, 7, 8. It went out to 20 odd reviewers. For every reviewer that scoffed, we would recommend a reviewer that supported. And this became a game. At one point, it was like getting so stupid that Bob called the editor and said, look, why don't we just take a majority vote? Mm-hmm. Now, of course, at that point, we were one ahead. It wasn't totally innocent. And they published the article.
Mm-hmm. This is a quantum mechanical interpretation of your data.
Well, that's what people thought it was.
Right.
this was actually a consciousness interpretation of quantum mechanics.
And we're going to do a whole other interview on that,
Okay.
because I really like the way you talk about the psychology of subatomic particles.
Yes,
Brenda.
indeed. No, it was, I think people thought we were explaining our phenomena, our data, through quantum mechanics.
Right.
But it was actually the other way around. The data were telling us, as I was mentioning before, back to your rattlesnake.
Yeah.
There's probabilities and observations and interactions involved in quantum mechanics that are subjective.
Mm-hmm.
And if you don't acknowledge and incorporate the subjective dimension of reality, the proactive capabilities of consciousness, by however you define it, you're not going to be dealing with reality. You're only going to be dealing with descriptions of reality.
Mm-hmm.
Subtle but very important difference.
Mm-hmm.
That's a snake. I'm a human. I'm objectifying, but let's dance. Now there's something going on
The
here.
snake and I formed a covalent bond, you might say.
or at least some kind of a bond. I don't know how but you connected.
Uh-huh.
There was a relationship that was developed that had a subjective aspect for both of you.
Yes.
Both of you were experiencing something quite unusual.
Mm-hmm.
That was an anomaly both for a snake and for a human. And that changed the world because it altered the probabilities. Now there's an alternative. We can kill, we can run, or we could dance.
Mm-hmm. What you're saying is that when your operators, as you call them, interacted with the machines, they're also forming a kind of bond.
That's what they would tell us.
Yeah.
They would say that it worked best when I felt that the machine was like an extension of myself. One analogy was, one person described it. It's sort of like playing a musical instrument. You can play the notes or you could play the music. Mm-hmm. But when you're really into it and you know what you're doing, it's not a cognitive process. You and the instrument are one. Mm-hmm. And you are not making the music and the violin is not making the music. It is the two of you working together. Yeah. I love that analogy. That's what's going on. Mm-hmm. Bob used to like sports analogies because Bob was always into sports. But it's the same thing. When a team is working together, you can watch them out there and it's almost like watching a dance. They know where each other is. Yeah. It's a choreography. Mm-hmm. And something magical is going on. They know where the ball's going to go. They know, and I think a lot of them will admit that there's something beyond just the individual players.
Well, ultimately, even though you spent 28 years within the School of Engineering looking at this problem, my sense from talking to you is that a poetical description is more apt than a statistical one.
I would say so. I mean, the statistics were important, and we needed to do that. We needed to do the very rigorous research. But Friedrich Nietzsche used to cork off some really great lines. One of them that I've always liked is, I should love my enemy because he brings out the best in me. When people, you're under scrutiny and people are waiting for you to make one slip up, you'd better be good. You better watch it. You can't afford to mess up. You can't afford to get sloppy. And so you end up doing much better work. Mm-hmm. And we were always aware of that. We were aware that, whether it was the university, whether it was the skeptics, whether,
You always felt that pressure.
You're always ready.
And I think, as you mentioned in a previous interview, your fellow parapsychologists were probably the toughest critics.
Well, I don't know why, and we could talk about this at some length, the philosophy of this whole thing. Why people are so threatened by the possibility that there might be something else going on than what you already believe. Mm-hmm. Why is that so scary? What does that do to the psyche that says, I don't want to acknowledge this.
Yeah.
And yet, these anomalies, these phenomena, these psychic, whatever you want to call them, they've been around since the beginning of time. They've certainly been around since the beginning of recorded history.
Yeah. Well, we have this idea that previous generations were superstitious fools.
Right.
And now we moderns, we have shed all of that superstition. And what you're doing is you're bringing up the shadow of superstition, the rising tide.
Why do you have a devil's pitchfork on your door?
Yeah.
Yeah. What is going on there? And this isn't, and yet it is really the exploration of these anomalies. It has played such a major role in driving the progress of science. Mm-hmm. We wouldn't have statistics at all if it wasn't for psychic phenomena.
That's right. J.B. Rhine's early card-guessing experiments were greatly augmented by his association with Fisher, the great statistical pioneer.
Isaac Newton once claimed that we ought to look at the role of imagination, the role of imagination on the casting of dice.
I see.
Keep going and going. Mm-hmm. And, what is going on? Why this is always here. It is constant, and yet it is resisted. That is another whole ball game, and something that one could explore for hours on end. But as somebody with a semi-psychological training, I find that part more fascinating than the phenomena themselves.
Well, but of course, as a student of culture, I'm sure you know that there's been an esoteric tradition throughout human history, East and West. And Isaac Newton, for example, was deeply interested in alchemy. He thought it was much more important than his work in physics and mathematics. And
so was Carl Jung. Mm-hmm. And frankly, all of the founders of quantum mechanics were into esoteric traditions. Yeah. Pauli was into Kabbalah. Schrödinger was into the Indian traditions, the Upanishads. Bohr was into Taoism. These guys were scholars. They had a broad background and understanding of knowledge and thinking and philosophy. Our current day physicists don't do philosophy. In fact, they don't even want to acknowledge anything. Philosophy is, that's what people look at when they can't do math. Mm-hmm. But it's all of the creative stuff has come out of an awareness of this other dimension. And yet we don't want to deal with it. Mozart said he used to feel the music sort of flowing into him from somewhere. He didn't create it. He recorded it.
He used to say to himself, "Thank God it sounds like Mozart."
But, there is this need, and for me, the concept, this keeps coming back to this fear of uncertainty. Mm-hmm. The fact that we as humans have this desire to be in control. Yeah. We want to know, we want to predict. We will name the hurricane, because then we have control over it, right? But still, it gives you the illusion that you have some control. Mm-hmm. Oh, yes, well, this is Hurricane Joe. Joe is coming at 120 miles an hour, and it's moving from the northwest to, now we know everything we need to know about Joe the hurricane until it hits you.
Well, I can well imagine that in the environment of Princeton University, you run into a lot of people who figure that they're very, very smart and they know it all.
Oh, yeah. Well, you don't get into Princeton unless you're very smart.
Yeah. But let me ask you this, Brenda. You were there for 28 years. What did you get out of it personally?
Oh, Jeff, that's hard to say. I'm a strange sort of person. I think I have to confess I took a personal satisfaction out of bucking the system and winning. Mm-hmm. I can't say that's true of Bob. Bob didn't have this sort of vindictive side. Bob was there to learn. Mm-hmm. And I think what he got out of it was the fact of his own understanding of what was going on expanded, that his way of perceiving the world of physics, of engineering, whatever, had added another dimension, that he had learned something new. I think he was very sad that he couldn't teach, because he was such a wonderful teacher. Mm-hmm. I mean, his students adored him. He had generations. Most of the people who are running the space business these days were students of Bob Jahn's years ago. And they still remember him with such fondness.
Mm-hmm. But the university clamped down on his ability to teach any of this material.
Yeah, he could always continue to teach his aerospace. Mm-hmm. This stuff was a different matter.
Yeah.
They didn't want us to pervert the minds of their students. Mm-hmm. We don't, and the funny thing is, they'll go about saying to the student, welcome to Princeton, where you can ask the hard questions. Well, except for a few questions that you really shouldn't ask. Uh-huh. We even had one student who wanted to do an independent project with us, whose advisor, his faculty advisor, told him, you don't want to do that. Your department, that's terrible.
Terrible intellectually, but it might have been good career advice.
It might have been, if pragmatism is where you're at. Yeah. And if you want to go out and make a lot of money so you could contribute to the alumni fund, hey, that makes a lot of sense. But if you want to educate a bright young mind to think independently, mm-hmm. to question the big stuff, you can't shut them up. But on the other hand, I guess one could argue that a really inquisitive and bright young person isn't going to be shut up easily. Yeah. And a number of them found us. Mm-hmm. And we have a community mm-hmm. that we refer to it as the pear tree, which is this community of people who have been affiliated with PEAR or ICRL. Mm-hmm. Many of them I've known since they were high school students, and now they're professional tenured professors.
ICRL, the International Consciousness Research Lab.
Right, which was the follow-on. Bob used to refer to it as the next lily pad we would jump to when we closed the PEAR laboratory. Mm-hmm. And ICRL it's a nonprofit. It's not constrained by anybody other than our own board of trustees. We can ask any questions we want. We're limited, of course, in what we can do, both financially and, staff-wise and so forth. But, it's so much freer. Mm-hmm. We don't have to answer to people who say you're not allowed to think that. Mm-hmm. Thinking aloud. I love that concept. Yeah. Thinking is allowed. Yeah. You cannot tell a person you can't think something. Mm. For me, back to your question, there was this sense of satisfaction that we had managed to stay alive for 28 years using the Princeton name, using its reputation to do what we felt was right, and get that word out there in some way to a community, a modest community. It's not the whole world, but mm-hmm. there are people who wanted to hear it. That was very satisfying. When, for many years, we used to have a nearby school district bring their fourth grade. These were 11-year-old kids who were doing their first scientific project. I remember them calling me, the student, officer, very apologetically, do you think we could bring some of our students by? We've been they're doing their first scientific studies, and we would love to have them go to a science lab, but we've tried a number of different laboratories at the university or other universities, and we keep being told that they don't have time to waste with a bunch of little kids. Okay. Mama here goes, and I said, I can't think of anything more valuable than spending my time interacting with a bunch of little kids. Bring them on. Mm-hmm. And we had these kids coming. There were 4 different schools and 4 different teachers. These were their gifted and talented. They were over about 10 years. I figured once that we probably had about 1,000 students come mm-hmm. through our lab. Mm-hmm. These kids were doing their very first science projects on consciousness anomalies. Okay, brilliant ideas, open minds, excited. Loved having them. They would come, for a morning. We would show them around the lab.
Well, it's nice that the university didn't clamp down on that.
The university didn't know about it.
Or they would have.
Or they might have.
Yeah.
They just came, and we didn't announce it.
Uh-huh.
That was between us and the school. It wasn't the Princeton School District. It was another one.
Yeah.
Okay? No, we did not announce this. If they saw the kids there, I don't think anybody thought anything of it.
Mm-hmm.
But it was just wonderful. When we closed the program, 28 years, later, it was after this, the kids stopped coming, shortly after the 9/11 event. I think their school district felt that field trips were too risky there. But when the lab was closed and there was an announcement, we got a lot of publicity when we closed the lab. Even places like Science and Nature mentioned us. They wouldn't mention us in all the years we were doing the work, but they were very happy to report that we were closing. I forget which one it was, had a headline that said, "The lab that asked the wrong questions." I don't remember but both of them mentioned that the university had shut us down, which of course it had not. But it did give us some publicity, and I get an email from this kid who's now an engineering student at Carnegie Mellon, who said, "I read that the lab was closing, and I was rather sad to hear about it. You probably don't remember me, but way back when I was in 4th grade, I came to your lab, and that was one of the major influences that made me decide I wanted to be a scientist." Well, Jeff, it doesn't get much better than that.
Yeah.
What more could you ask for in terms of your work? What did I get out of doing this work? I got that letter. I got this wonderful feeling of connecting to people who wanted to hear the message that we were pronouncing. And the people who would write back and say, "Thank you so much for listening to me. Thank you so much for reassuring me that I'm not crazy. Thank you for doing this work, because I've always felt there was something to this, but, people would put it down and ridicule it. But you've done scientific work. You have demonstrated it under rigorous scientific conditions that this is real. Yes, it's real." And that sense of connection with these people, I think, has been the most gratifying part.
Well, that's why I do these interviews.
Yes, I can understand that. People want to hear it. They're hungry for it.
Yeah.
They are tired being told they have to choose between their head and their heart. They have both. They want something that speaks to their heart but doesn't challenge their head into, in cognitive dissonance. Give me a way to think about this from a scientific point of view. Can I do science on a topic like this? Yes, you can.
Well, Brenda Dunne, what a joy to share these memories with you. Thank you so much for coming to Albuquerque and being with me.
This has been a delight, Jeff. I'm so glad to share it, and I'm so glad you're doing what you're doing and getting this out to a broader world. The world is hungry for this message and the messages that you're bringing. Thank you.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. the topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download a free PDF copy of issue number 8 of the New Thinking Aloud magazine, or order a beautiful printed copy. Go to newthinkingaloud.org